Welcome to the Daily Apple. I'm your host, Kevin White. Emma Ryan and I will dive into all topics related to the science of longevity, along with some other subjects we just find of interest, with the hopes to provide useful information for everyone. This stems from my personal interest to optimize the human condition, to not just live longer, but to live better. Hello, everyone, and welcome back to the Daily Apple. I'm Kevin White, your host, and I'm here with Dr. Benjamin Miller, true authority in the field of aging. He is a professor and program chair of aging research at OMRF here in Oklahoma. He's originally from Berkeley, which is where we stole him from. He's also tied with the Oklahoma Center for Geroscience. He is a recent past president of the American Aging Association, and he's just truly an authority in this field and very knowledgeable. We're going to talk about his new clinical trial. He's doing some cool, wild things, focusing on folks that are 60 and over and how they respond to age. And some people they respond well, some people don't, and really digging into that. And so if you're 60 and older, or if you know somebody that's 60 and older, this really pertains to you, which is pretty much all of us. So anyway, I really appreciate you taking time with us here, Ben, and look forward to talking.
Thanks. Glad to be here again.
How have you been?
I'm good. I'm surviving. Yeah.
Yeah. Life is different right now. We just kind of talked about some activities of the summer, a little bit off cameras. I know you've been on this before, about a year or so ago, but I kind of want to just touch on, why did you get into aging research in the first place? And was there a moment that you thought, this is the thing that I want to dedicate my career to? Because you really have done that.
Yeah. So I started, my research was basically in human intervention studies, and I really studied metabolism during my Ph.D. So I did my Ph.D. at UC Berkeley, and then I went overseas to Copenhagen, Denmark, because there's a world famous muscle research center there, and they're very famous for doing invasive studies. So the use of the muscle biopsy really started in Scandinavia, and I went over to learn those studies, and I was really focused on muscle itself, but also the connective tissue in muscle. And then when I took my first actual faculty position, I really saw all these interesting questions related to muscle and aging that I really wanted to explore. And I didn't really come from an aging background. I came from a physiology background and biochemistry background, and actually a little bit of exercise physiology, or mostly exercise physiology. And I really wanted to start addressing questions related to aging. So when I started my own lab, that was definitely the direction I went. And really started, some of my first studies were on caloric restriction, looking at the effects on muscle. We got into some of the rapamycin type studies, long-lived models. But I morphed into really studying both aging muscle as sort of one side of the lab, and then basic biology of aging, what causes us to age and how to slow that down, which takes me into muscle and several other tissues as well. But it was really that when I started my own lab, that's what I wanted to do. And I've been fully immersed into it ever since. But I do kind of feel like I came to aging a little bit as an outsider. I didn't come from a lab that studied aging. I was a true physiologist and sort of applied what I know about physiology to aging problems.
So talk to me a little bit about, we get into different things. We always think about, sexy molecules and stuff like that. And I always go back to exercise as kind of one of the biggest elixirs of longevity. I mean, it just continually goes back to that. But can you tell us, you kind of touched on that, what's happening biologically when we age as far as the muscle and strength and all that from your perspective? How do you think about that?
Yeah, for one thing, to address the first thing you brought up, we study all these drugs, and our lab does that too. But even within the lab, we talk about how all these drugs are just trying to be as good as exercise. Okay, we know that exercise works, and we know that exercise has these effects everywhere in the body. Like, there's not a tissue, even though, like, if you're exercising and say, I'm running, I'm using my legs and my heart's pumping, it's still every organ in your body, your liver, your pancreas, your brain, all of these things actually get positively impacted by exercise. So we know that exercise works. And then, we're still trying to understand exactly how it works, and we'll get into that in a little bit. But, as the root cause of a lot of the problems that accumulate with age, our lab is really focused on probably two of them. One of them are the mitochondria. Okay, so
Mm,
the energy producing organelles in your tissues and the problems that can go on in the mitochondria. And then the other one is something called proteostasis, which is basically protein homeostasis. So maintaining your proteins, which are the structure of everything in your body, keeping them in a more young-like state because they tend to accumulate damage over time. And, that damage they accumulate over time is, what we see as aging. A real visual of that is skin, as you get older. The quality of some of those connective tissue in the skin, the proteins, goes down with age. But,
mhm.
we're kind of studying that in all the other tissues in your body.
You know, like you said, the proteins accumulate damage over time. How does one keep that from happening? Like as you see that, and as you're studying that, what's some of the best ways that that we can mitigate that? You hear a lot about protein intake, how that's important as we get older, and all that sort of thing. But whenever you look at that and think about it from a practical standpoint, what do you say?
Yes. So I guess the analogy here is like if you have a vehicle, you can do preventative maintenance on it, all right? And that's relatively low cost over time, but you keep things from getting bad. Whereas if you don't ever do any maintenance on it, then something catastrophic happens, and that might be fixable or it might not be fixable. And it's harder or more costly usually to fix it after something catastrophic happens. So that's the same thing with proteins. So you can do things preventatively and keep damage from ever building up to begin with, or you can take what is usually the model in medicine right now is when things fail, then you try to treat them. So
Mhm.
when things manifest as disease, then we try to fix them rather than preventing it from ever happening to begin with. So the preventative is actually a lot easier if you have the foresight to do that. Okay, so as far as proteins, in the body, we have things that are damage causing. So if you have metabolism that's not smooth or efficient, you build up byproducts. And those byproducts of the metabolism can modify your proteins in a way that those proteins become less effective, or they tend to bind up other proteins around them, so they all become ineffective. So if you think of something like Alzheimer's and you think of plaques in Alzheimer's, what plaques are a conglomerate of proteins that are stuck together and not working, doing what they can and accumulating. And we study that process in other tissues as well. Although we know it well in the brain, people see that as Alzheimer's or Lewy body dementia.
Mhm.
That happens in all your tissues. And we sort of study how to keep those proteins from getting to a place of damage and irreparable repair.
How do you do that?
Well, exercise is number one.
Yeah.
And the way I like to think of the body is that if you think of about like a clean mountain stream, that is flowing and the life there, versus like the stagnant pond, which is just a sheet of algae over it. And I think that's a good visual for what we call flux or movement in your metabolic pathways. So
Hmm.
your metabolic pathways are designed to run, okay? When they don't run or they're not active, things tend to go bad. So movement, even of your physical body, creates conditions where you have to move blood, you have to move nutrients, you have
Hmm.
to use those nutrients, and you keep this flux going through the body. When you're sedentary, when you're not moving, when you're not using all the energy that you're bringing into the body, and you're storing it, that creates more sort of stagnant conditions. Okay, and that tends to cause bad things to build up. So, we think about reactive oxygen species, we think about fatty acid products that aren't completely broken down. All these things can serve to modify proteins.
So really back to the movement thing. Here I am looking for the, sweet little cheat code and everything, and we're going back to movement. But it makes sense, and I like the analogy there. That's really important.
Yeah, and I always go back to movement, but
Yeah,
the drugs are attempts to activate some of those same pathways.
yeah.
Okay, and people talk about exercise mimetics, which are drugs that do the same things as exercise. Well, be a little bit skeptical anytime you hear that. Things can activate certain pathways that are active during exercise, but no drug is going to activate all the things that exercise or movement activates.
You're kind of alluding to some of the mitochondrial stuff is what I'm hearing too, which I want to pop into that and some supplements and everything that kind of focus on those specific areas. But what you're saying is exercise and movement really do all those things. And some of these pharmaceuticals that we'll discuss just kind of hit specific areas in those pathways. So, yeah, and from my time in medicine and in the traditional setting, it's always been people who are sedentary. Bad things happen to people who don't move. So
Right.
whatever happens,
Yep.
whether it's a procedure, whatever, if you're not moving, bad things happen. Uh, I guess we should get into your trial. We need to do that. I'm really excited about this. Whenever you emailed me about all the details, I thought there's going to be a lot of people interested in this. And I mean, you're talking about taking people who are 60 plus and you're evaluating exercise, and you guys are measuring all kinds of things with wearables and really evaluating what makes people respond well and not. Can you just kind of discuss that a little bit for me?
For sure. This is a study funded by NIH, and it's two sites.
Yeah.
There's one here in Oklahoma City, and the other one is in Pensacola, Florida, at a institute much like OMRF's, but a little bit smaller. It's called IHMC. It's a private research institute there. So we have two sites doing the exact same thing at both sites, just increasing our recruitment, ability to recruit more people. So what we do is we recruit people 60 or older who are not currently regularly exercising. Okay, so we have certain criteria of whether
Uh,
you're regularly exercising or not, and that's 2 or 3 days of moderate to vigorous activity. And we do a lot of screening to get the people we're interested in, and they go through 16 weeks of supervised exercise training. So each person basically gets a personal trainer. You're getting personal training for free, basically. And then at the end we have some assessments through that, including things like VO2 max, a biopsy, a muscle biopsy to look at things like mitochondria in the muscle, some blood draws, some strength testing, DEXA scan, and then, as you mentioned, we have the wearables as well. People will be wearing an Aura ring, and they'll do some cognitive testing, some functional testing, and we'll do all that pre and post. And at the end of 16 weeks, we have two criteria. One is the VO2 max, and one is the force per cross-sectional area. So specific force, basically, of a leg extension. And we have established minimally clinically significant values for improvement in those. And if you meet both of those, you go one direction. If you meet one of those, you go a different direction. Or if you meet neither of those, you go a certain direction. And you're going to either get a another boosted session, another weeks of exercise training, or you'll graduate into just a life, whatever you want to do. Okay. And then we bring you back at the end of that period and do some more testing. So by the end of this, we expect to have about a quarter of the people that don't respond, a quarter of the
hmm
people that are double responders, and
hmm
then, the rest of them maybe respond in one or the other.
hmm
And we then, through all these different metrics that we monitor, I forgot to throw in CGM in there as well, continuous glucose monitors.
Oh
So
yeah.
through all this data from the Aura, the CGMs, the strength training, the VO2 max, blood draws, the muscle biopsies, and the multiomics that we'll do with that, we hope to be able to find factors that predict whether you're going to respond well or not, or what kind of exercise you do respond to. What are those factors that, so we can, moving forward, say, okay, this person has these sort of biological qualities, they're going to respond well to this, or we might need to do this to help them respond to the exercise training. So, it's getting at this personalized medicine,
Yeah.
and adapting it to exercise in older individuals. Because we know, and I should have started with this, if I put 100 people on an exercise training program, some of them, a quarter of them are going to do really, really well. Half of them are going to have some response to it. And, a quarter of them might not respond at all. And, that's something we want to avoid. We want to make sure that everybody reaps the same benefits.
So I've got a lot of questions here, but what do you think makes people respond well versus people who don't? And by the way, this is, we're taking 60 plus people who are not exercising in any form. Is that correct?
Right. I mean, we'll have some people in there that, walk their dog 3 days a week and things like that, but not regular structured exercise.
Okay. So if you're walking in the evening or doing something, I mean, you ought to, yeah, there's a lot of people that will be interested in this. So what multiomics are you checking here on this?
We will be doing proteomics.
Yeah.
We'll do that both in the muscle and in the blood. We'll be doing some epigenomics. We'll be doing some transcriptomics and maybe in some limited metabolomics. But
Hmm.
we're also respiring the mitochondria from our muscle biopsies. So we're
Hmm.
looking at how well mitochondria work.
Yeah.
And, so all of these factors plus
Yeah.
CGM
Uh-huh.
plus all the sleep data and everything else from your aura.
Yeah.
And all these factors are going to go into this multidimensional modeling
Right.
to try to figure out these predictions.
Uh-huh. And gosh, yeah, Ben, this is a huge deal, and I'll tell you why. If
Yeah.
somebody went through a precision medicine program that has a fraction of all this, the cost would be immense. And
Yeah.
so you're having scientists evaluate you on a personalized format, and anyway, I could go on and on. So I
And
need to get,
we're paying people to do this.
yeah. Yeah, I know. I need to get, gosh, I need to get my parents in this. What's the age limit there as far as the top end?
We don't have one. We recently had someone in the 80-year-old range screening. So
Okay.
as long as people, we'll look at some orthopedic sort of issues and stuff to make sure that they can complete the exercise training, but there is no upper limit to it.
So how many people are you looking to enroll in the study? What's your mark?
So
What do you
over
want?
4 years, we're hoping to have roughly 70 to 90 people that complete.
Mm-hmm.
We'll enroll more than that. We anticipate we'll have some drops. We haven't yet. So, like right now we have 16 to 18 people going,
Uh-huh.
which is a lot to manage at one time. People getting 3 days a week of
Right.
supervised exercise training.
Right. So what do you think makes some people, you take one person who's 65 and another person who's 65, and you say you just do resistance, you're trying to add on muscle. As we know, sarcopenia and muscle wasting is a real problem as we get older. What do you find makes one person respond well to the same exercise regimen versus another? Am I making
Well,
sense there?
I mean, this is what the study is. I mean,
Yeah.
we know that there's heterogeneity in the way people respond.
Yeah.
We don't know why that is yet. And that's exactly what this study is trying to figure out.
Do you have any
Why?
ideas
Um,
or thoughts?
no, I mean, I not going into it. I mean, there's some of this is genetic. Um, and some people, because of fiber types, are going to be more predisposed to say aerobic exercise or strength training. But the what's cool about this study is that we're doing both of those things, and we're trying to get them to respond to both. Admittingly, like I tend to focus on aerobic exercise.
Right.
Sometimes strength training falls to the side a little bit for me, whereas other people just love to do the strength training. And no time for aerobic training. So we're using a combo of those and want people to respond to both.
Yeah, the nice thing about this, if I'm hearing you right, you're taking people, they're being separated into these different arms, but they're by the time they're finished, they kind of have actionable data on what works best for them or not. So they can kind of moving forward, even outside of that study, use their time more efficiently and focused in their
Yeah, we
workout regimen.
hope to
Am I
get
right?
to, I mean, that's the end goal there.
Yeah.
Just to correct something slightly, everybody is going through the exact same first 16 weeks. It's just when they get to that 16-week point, we see, well, did they respond or not? Do they might go a different direction in the study?
Gotcha. Okay. So if they get to 16 weeks and say they don't respond as far as to resistance training within your parameters, what would happen to them? I mean, they would.
Well, we do what we call boosting the training to see if
Okay.
we can,
Okay.
to see if we can still yet make them respond to it.
Yeah, I see. So, and you'd mentioned multiomics, and I want you to explain that just because of many of our listeners. I've been reprimanded by people saying you get too sciency, so stop talking like a doctor and explain it to us like we're kids. So kind
Mhm.
of explain that a little bit as best you can from a layman's perspective.
Yeah, if you think about something like, I'm going to go measure blood glucose, and we measure one thing, we measure the glucose value in the blood, and that's
Yeah.
really valuable for some things. Over the last 10, 15 years, we've developed instrumentation that can measure thousands of things at a time. Okay. And that gave rise to what we call the omics. So if I'm interested in proteins, I'll do proteomics, and I can measure thousands of proteins off a given sample.
Hmm.
Or if I'm interested in the metabolites in our body, we can measure thousands of metabolites at once, and that's called metabolomics. So we have gotten to the point where measuring these things are possible. It's making sense of all those data that's become the challenge now. And that's what's given rise to what we call bioinformatics or data science, where we're just trying to understand, when you have thousands of data points, how to make sense of all of that.
So, um, so people are getting free supervised exercise training, tons of personal
Hmm.
health data, and they're getting, which would generally cost them 10,000 or up if they were seeing a personalized physician on this stuff, and then they're getting paid too. So that's just I think you're going to have a lot of people signing up. If they're not, they're just insane. Getting and it's 3 days a week, you said, for 16 weeks, and then they move forward on a different path, whatever path that is, but everyone goes
Yeah.
through the same program for 16 weeks.
Yeah.
Okay. All right.
It's pretty, I mean, there's a little bit leading into that, a couple weeks of some pre-testing, some familiarization to the equipment.
Hmm.
But some of the things we measure, cardiorespiratory fitness, okay, VO2 max, that's a test that predicts morbidity and mortality almost better than any other test.
Oh yeah.
And nobody just goes out and gets that on their own.
Right.
We do that here in the strength testing and the DEXA scans and everything else. It's really valuable data. We do EKGs,
Hmm.
that kind of stuff during the testing. All stuff that people can take with them to their physician if they want to.
Yeah. Yeah. Um, yeah, we do VO2 max on all of our clients here, or definitely offer it to them. And you're absolutely right. It's extremely valuable. Kind of explain to that whenever somebody's listened to that. Of course, if they've listened to us talk on this podcast, they've heard us say the words VO2 max over and over. So kind of explain that, because you're kind of an expert in that area. When you look at a VO2 max, how do you explain that to somebody, what that's actually measuring?
Right. So VO2 max, or what also called cardiorespiratory capacity,
Hmm.
we think of, most people don't understand the reason we breathe is to bring in oxygen
Yeah.
that eventually gets to your mitochondria to produce energy. Okay. So that oxygen has to get all the way from the air, all the way to, say, my muscle and the mitochondria in that muscle, to use it to produce the energy we need to do anything. Okay.
Hmm.
So there's a cascade that oxygen has to go down to get to that final place where it's needed to make energy. So the ability to bring in oxygen for your heart to deliver blood, which carries the oxygen, to the tissues. And when the blood gets to the tissues, for your mitochondria to actually use that oxygen to make energy, that is what a VO2 max is measuring. So your
Hmm.
maximum ability to use oxygen to make energy. And that is a surprisingly, to me, it's not surprising, but it's a very good predictor of morbidity and mortality. And
Yeah.
if you get to sort of a minimal point of your VO2 max, or your maximum ability to use oxygen to produce energy, there's a like a threshold of a minimum where you're basically not not independent anymore.
Right. Yeah. I've
If you
told
think
people.
about just the ability to walk up a stairs or get
Yeah.
out of a chair or do anything that requires you using oxygen to make energy, so there's a minimal threshold for that.
Yeah. I I use the analogy when I tell people, and you can tell me if this is completely wrong, but I always, when I'm explaining it, and it's not as thorough as your, as what you just said, but kind of like how efficiently the pistons are firing in the car, how efficient the motor is actually running, and how well it's utilizing fuel. And if you've got a really poor VO2 max, you're really not long for this world, or you certainly don't have much resilience if you have some significant disease going on.
Yeah, that's true. And that's the analogy used. I use it slightly different. I use a car engine to explain mitochondria, how
Hmm.
they work. So a car engine, you bring gasoline or petrol, that's the fuel.
Yeah.
It has a bunch of carbon bonds in that fuel that gives it energy. And then you have oxygen or air intake into the engine. And then there's a spark plug that releases that and that combusts that fuel, and that moves the pistons to create work. And it also creates heat as a byproduct and carbon monoxide as a byproduct. So that's an engine. Now, the parallel to that in us are the mitochondria. So we breathe in oxygen, just like a car needs oxygen, or the engine needs oxygen. We bring in nutrients, carbohydrates, and fats, which are the same thing as the gasoline.
Hmm.
Our mitochondria basically, think of it as combusting. It's not really combustion, but releases the energy. And our byproducts are CO2 rather than carbon monoxide. We generate heat as well, just like an engine does, and then we convert the rest of it to usable energy. So, kind of the same thing.
Yeah. I'm going to steal that from you, Ben.
Sure, go for it. I don't think I'm the only one that uses it. So.
Let's talk about the future of aging science just a little bit. What are things, how close are we to interventions that slow or reverse or I'm not going to say reverse. I don't think that's as far as
Appreciate that.
interventions that really slow
Yeah.
aging. Yeah. What do you think about that?
I do appreciate that slight correction there.
Yeah.
I'm all about slowing the aging process. I think
Yeah.
reversing it is sort of a long, I don't know if that's feasible or not, but I
Right.
think
Right.
slowing it definitely is. So I don't think we're that far off. Okay. So there's a lot of things that are potential. To have the infrastructure to be able to test them is the tricky thing. So if you go to the FDA with a blood pressure medicine, and you show the FDA, they'll say, what are you going to measure to determine if this works? And you say, okay, it lowered blood pressure by, mean arterial pressure by 10 or something like that. That's your objective measure of whether it worked or not. So if we go to the FDA and say we want to slow aging, well, what is it that you measure then?
Mm-hmm.
Okay. That's been the tricky part. And to have an infrastructure in place, or even having biomarkers that show that you have slowed biological aging, that is the tricky part. But there's things going in place right now that I think are going to make this feasible.
Mm-hmm.
And I'm involved with a couple of these potentials. And once we have that what is the measurement, then you can go take something into an intervention and see whether it works or not. And there's a couple of the drugs, a lot of them that we're familiar with, that are going to be the first to be tested for this. And most of the first ones that are going to be tested for this are repurposed
Right.
drugs that we already know.
Like your rapamycin and all that.
Yeah, I think rapamycin's, all the data in animals and everything like that is so great.
Yeah.
I don't know that that's going to be the first one to go to a clinical trial in humans, just because the dosing hasn't been worked out yet. I mean, there's people working on that for sure, but
Hmm.
I see something else like SGLT2 inhibitors,
Hmm.
GLP-1 agonists, or
Yeah.
metformin are the ones we see the most. And, I have a clinical trial and have a lot of studies into metformin. I
Hmm.
personally don't think that's right for everybody, but, it's such a safe drug and other things that it might be one of the first that goes forward.
Yeah. What you said, things you measure. What are some things that you think will be measured to kind of
Yeah,
gauge?
I don't think it's going to be one thing. I think it's going to end up being a composite.
Sure,
Um,
that makes sense. Yeah.
yeah, it'll be a composite of, I think, functional type outcomes.
Hmm.
6-minute walk, cognitive testing, something you can do on a phone, something you can do on a blood sample, and all these things sort of come together to give you a metric
Yeah.
that, and you have to show that you can move that number or whatever by an intervention that slows the aging process. That number is going to change. Or if someone is in worse health, that number is also going to change. We have to show that it tracks those things.
Hmm. We visited a little bit, and I know you're well, you are an expert on mitochondria, and there's a lot of noise about this. And as we know, it's one of the 12 hallmarks of aging, of course. And I've been doing a lot of reading on mitochondrial dysfunction and all that sort of stuff, and it gets pretty complex. And as our last conversation and learning more about this too, it actually does a lot of communication among the cells, and there's a lot more to it than what people know about. But kind of discuss about that and kind of talk about how you see mitochondrial dysfunction as it pertains to chronic disease and aging and all that stuff, and how to mitigate that.
Yeah. So, admittingly, one of the things that have been hard about mitochondria is we see that it's associated with aging and disease.
Hmm.
It's harder to show that the problems with mitochondria cause the aging or disease versus it's a byproduct of some disease process or aging. Okay. So is it just a passenger or is it actually causing these problems? I kind of think that it is part of what's driving the problem. Okay. It's not just a passenger, but I just wanted to throw that out there.
Hmm.
So I like to think about it this way. You brought up the term resilience before,
Hmm.
or stress resistance is another aspect of that. Now, if you think about a cell, and it has, or a tissue in your body, and it has a certain amount of currency, and let's call this energy. Okay, say I have $100 and I have to give $60 just to pay the bills. Okay, no matter what, I'm paying that. In your cell, maybe that's the $60 just to maintain itself, normal processes. And then I have $30 that, I have to pay for groceries or something like that. And then your cell has to do something else with that $30. All of a sudden, when the cell gets challenged, then, and it's out of energetic
Hmm.
currency, it can't adapt to that challenge. Okay, when we're young, and stresses hit us, hit our cells, hit our whatever, we have that reserve to be able to deal with those things. Everything in your cells and your body costs energy, and you have a certain amount of it on demand. Okay, we have a lot of it stored, like in adipose and things like that. But in a cell at a given time, if you have a bunch of things trying to tap into those those stresses and everything, tap into those energetic resources, you have to have it immediately available. And that's what the mitochondria are there for. And if your mitochondria start to not work as well, and you don't have as much energy on demand, then something's got to give, right?
Hmm.
You can't simultaneously maintain all these proteins and stuff in your body, in your cell, while you're getting this immediate stress that you have to adapt to. Okay, so it becomes a trade-off. So everything costs energy, and then as your cell gets older or less healthy, it starts to make compromises.
Yeah. There's no emergency fund. I get it.
No, no reserve. Yeah.
So here's a big question, and this would be like half a day. for you to discuss, and I'm asking you a lot here. But what are your thoughts on supplements as far as like NAD, urolithin A, to name a few? We've already discussed rapamycin and metformin, but NAD and urolithin A as we're talking about mitochondrial health and resilience.
Yeah, you're going to be disappointed in this answer, but I don't actually give them a lot of thought. So I'm involved with some studies peripherally looking at NAD metabolism. Okay.
Hmm.
That doesn't necessarily mean the supplements that are on the market or whatever are doing anything. And
Yeah.
I tend not to pay attention to those very much, but there's definitely something energetically where NAD, NADH are impacted.
Hmm.
I don't know how well the supplements are impacting that. And then I think of things like metformin and rapamycin as, drugs. So a little
Hmm.
different than an unregulated supplement. Those I think have promise. I mean, I really like how rapamycin works.
Hmm.
And I think it has a lot of merit. I think the dosing, because it's an immunosuppressant, is, a tricky thing. But obviously, as you know, there's people out there using it right now.
Hmm.
Metformin, a body of literature that I'm involved with and studies I've done showed that metformin can inhibit some of the positive effects of exercise, especially at the mitochondria.
Right.
So I don't like the idea of, people that are interested in their health normally they don't just do one thing, they do multiple things. And doctors are very familiar with drug-drug interactions and how two drugs might not work well together. And in my opinion, and opinions of others, we have to consider exercise like that. So we have to consider exercise drug interactions. So you
Hmm.
don't want to be going through this exercise training program and then taking a drug that's mitigating those positive effects. And, we have shown that metformin can do that,
Hmm.
mitigate some of those positive effects. I actually think metformin is really great if you're diabetic or metabolically unhealthy. It works really well, but for people that are healthy already, I'm cautious of it. Okay. And I think we still have to work some of those things out with the rapamycins of the world and some of these other drugs as well. How do they interact with other health promoting behaviors?
Yeah. Yeah. I've got, a lot of people are into the, precursors as far as the NAD and all that stuff. And
Yeah.
there's no real way to measure. I mean, sure, in theory, my understanding, NAD, declines. We need that for, functions in the cell, the Krebs cycle, all these things, the precursor to the electron transport chain and all that jazz within the mitochondria. But there's no real way to measure outside of the way somebody's feeling. It's like they might feel great if you're getting them, NAD sub-Q injections. And, the question is it really getting to where it needs to go or not? And there's no real way to measure that outcome. So,
Yeah, and that's the key thing. I mean, the mitochondria is where, and you can even
yeah.
take it further, in the mitochondrial matrix is where that's going to matter.
Hmm. Hmm.
Whether it gets there is
Yeah.
another question.
Yeah.
And, it was only last year or 2 years ago now, that they've identified some of these transporters on the mitochondria
Hmm.
that can transport these metabolites. So, there's a lot to figure out there yet.
Yeah. What, as with all this stuff, what kind of aging myths drive you crazy? I know there's so much, and you probably don't even listen to all the noise out there because you're so busy with doing the actual science. But like, what kind of stuff drive you nuts that is in this space? Because there's all walks of life.
Yeah. Um, there's this idea with some that it's just genetics, whether you're going to live longer or not.
Hmm.
You know,
Yeah.
Certainly genetics is a component of that, and people like to this reference is getting dated, but someone would like to point out like George Burns and say, "Look, he lived to 100 years old and he smoked cigars all this." Like, of course, like there's always these outliers, right?
Yeah.
But I think I relate genetics as sort of a hand that you're dealt. Like if
Hmm.
you play poker and you're dealt five cards, and they can be a really not a great set of cards, but if you play it right, you might win a hand.
Right.
But you could be great, get five great cards, and be a very poor poker player and lose. That's the genetics is what you're dealt, and the environment or how you take care of yourself is how you play that hand.
Hmm.
So no matter what your genetics are, you can play with that in good or bad ways.
Hmm.
And I don't really see a shortcut to good health.
Hmm.
It's something that you have to be mindful of, and just making it part of your day. Like for me, this shows a bias on my side a little bit. I'm a very big advocate for physical activity.
Hmm.
There's a lot of nutritional interventions out there right now. And, there's the caloric restrictions and the alternate day fastings and the
Yeah.
ketogenic diets and all these things, which, some have, um, positive effects. I personally view it as I have to exercise once a day.
Hmm.
Nutrition is something I have to do 24/7
Hmm. Hmm.
every day of the year. I
Yeah.
find exercise to be quite easy, in that respect. And it just becomes habit. And I think taking shortcuts to your health, rarely does that pay off, right?
Hmm.
Yeah, so those when I see this miracle drug or this miracle supplement,
Yeah.
like everybody else, that's what sort of drives me crazy.
Yeah.
And that you brought one of my pet peeves up earlier too, which was reversing aging.
Yeah.
Like, yeah, I don't.
Yeah.
There's a lot of people spending a lot of money on that potential right now, but
Oh, yeah.
they're people
That's
that have a lot of
nonsense.
money to spend. So,
Yeah. Um, as we're talking about stuff, before I ask you this, like you said, I tell our patients it's like brushing your teeth. You brush your teeth every day. Just equate it to that. It doesn't have to
mhm.
be long, doesn't have to be for, 2 or 3 hours a day, just something and consistent. You do it every day, at least I hope.
Yeah,
So,
right.
I can't get through this conversation without mentioning creatine. I have a lot of questions about that. That comes up a lot. I take it every day. As far as how that works in regards to the mitochondria and everything, are you familiar? I'm sure you are. We haven't talked about that before.
Yeah, so it's funny. Creatine's not new.
Right.
20
Yeah.
years ago, it was out there a lot. It kind of went
Uh,
away. And then it came back because I think people reformulated it so it's tolerable, to take it and things like that.
yeah.
It's getting a lot of attention in endurance sport right now, and power sports. I think
Hmm.
everybody in power sports and print and sprinting and those kind of things are taking it. It's your immediate pathway. It's energy pathway. It's that first couple seconds explosive pathway. It's your buffer to your body tends to protect how much ATP, which is your energy source. It tends to try to not to let that number dip, because then you get in trouble if that ATP is not around. And phosphocreatine is that immediate source to sort of buffer that before you kick in some other energy producing pathways. So, um, I have nothing bad to say about creatine, like phosphocreatine, and people who are supplementing with that seem to get a benefit from it. And whether that's an explosiveness or even with an endurance athlete, or I mean, I don't know, maybe you can tell me if people in the general public are taking it just for supplementing, or is it all attached to sport and exercise? I mean, that's what the realm I've seen it in.
Yeah. There's a lot with cognition now as well.
Okay.
We've got some clients that we're putting through this cognitive decline project that we're doing with Human Sync and Matt Camerlin with Optispan in Seattle, and that's
Hmm.
part of the deal what we're doing, and we've seen some success with that. I have just
Hmm.
subjectively. So, but of course, the largest part is with the exercise community. So,
Yeah. Yeah.
but yeah, very exciting stuff. I've been thrilled about the data I've seen about that. But I do want people to find out more, and we'll include this in show notes and everything about where they can enroll in this study of yours. And I'm really excited about that. I think it's going to have a lot of interest. And but you'd mentioned before we started recording about some frustrations and everything, and I do want to touch on that because whenever we got on, I could tell you were just kind of bummed a little bit, and was probably on your mind, but kind of explain that a little bit. This is kind of interesting, and people should
Yeah,
be aware.
so every day right now, I think about the health of science, not the science of health, but not just the science of health, but the health of science right now in the country. We have a lot of science skeptics in the country right now. And part of that, I think, has been bad messaging by scientists ourselves. I tend to do a lot of these kind of things and like to talk to the public. A lot of scientists are really, really bad at talking to the public. And
Hmm.
and in a language that the general public understands. So we've sort of always thought people would just understand why science is important. Okay. And now we're at this point where some people are starting to question the value of science. And that is coming, in the face of things like NIH being under threat and National Institutes of Health and the CDC and all these things that look after the health and well-being of everybody in this country. So everybody wants their grandma with cancer to get the best care she can, their mom, with diabetes to get the best care she can. Everybody wants that. What people don't realize is that care comes on the back of NIH funding. Okay,
Hmm.
so 90, I think it's 99% of approved drugs in the United States, the basic finding that led to that drug came from NIH funding. Like, that is basically saying every drug we use or approved in the United States right now, NIH had a hand in. Okay, and then you talk to people, okay, where do drugs come from? Many of them will say drug companies. Well, no, drug companies don't make those basic findings. NIH, universities, research institutes make those basic findings that then drug companies can generate a drug for to get out and treat. Every PhD that works at those drug companies have been trained on NIH dollars. Like,
Hmm.
if NIH goes away, so does the health and well-being of our country. Okay. And the reason I bring up the skeptic or the science skeptic is people, I think, have a hard time realizing how far we have come in, the last 150 years, and even then in the last 50, 20 years, about how we can live longer and healthier. And it's basically because of all these basic science findings. You don't have to go very far to make that, to track back to where those dollars came from that improve our health. Um, and that is all under threat right now.
Yeah.
We wake up every day with something new that we're dealing with as far as can we keep research going or not. So OMRF here is an amazing place to do science. Okay, we're a private research foundation. Most of the funding here comes from NIH. If NIH goes away, OMRF goes away. It's really hard to survive that. And it's funny, you talk to people and they'll say, if you take them around OMRF and they're like, or tell them what it's doing, they're like, oh man, that's great. That's amazing.
Yeah.
But at the same time, don't realize how we are able to do what we do.
Hmm.
So yeah, and it's all under threat right now, and it's been tough. So I've spent my life dedicated to the good health of other people.
Hmm.
And all of a sudden now I'm being told that that's not important. And this expertise that I work, I don't even know how many hours I work. I don't keep track because I never stop working. Like, I'm
Yeah.
always thinking about it. And that training I had over the last 35 years, it's suddenly people know better,
Hmm.
even though I've dedicated my life to this, every waking moment to it. Suddenly other people know better. It's been real hard to deal with. And I'd like to give this analogy, like, you would not want me to come and do the electric at your house. There's experts to do that.
Yeah.
You would not want me to do it. I'm not trained to do electrical work,
Uh-huh.
but yet everybody else knows better than the scientists right now.
Yeah.
I just don't understand that.
Yeah, I've always understood how important it is, but never as much as when I was reminded that first the American Aging Association meeting I went to, and you've got everyone presenting, PhDs from all over the world working on aging in general. And I realized, wait a second, everything we do as physicians, clinicians in the hospitals and everything doesn't happen without people doing that research. And that doesn't happen if it's not funded, like you said, 99% by the NIH, which comes from the government. So yeah, that's frustrating. I hope it
Yeah.
works out.
Yeah, everything you do as a doctor is based on evidence based. And where does
Hmm.
that evidence comes from? It comes from scientific studies.
Yeah.
It's not just drawn out of thin air, and it's crazy.
What's your vision for aging research in the next 10 years, 20 years?
Well, I want to be able to still be doing it. It's a
Uh-huh.
big thing. But I do think this this focus on the fundamentals of what's causing aging and then all these other diseases that emerge just as because someone's getting older. This ability to slow this process to be able to treat all these things sort of together at one time. And, this next step that we're going to take soon to try to actually treat that or it slow the aging process. I think that is super exciting. This idea that aging is malleable, right? It's not inevitable that we're all marching at the same pace to, towards this end line that we can slow that process down. We tend to think of things as modifiable and non-modifiable risk factors, right? And aging used to be this non-modifiable thing, and now, it's somewhat modifiable, and I think that's exciting. So, and as I say all that, we already know that exercise does it, okay?
Yeah. Yeah.
But we haven't done a good job of convince or of this is a behavioral issue maybe to get more people to engage in regular physical activity, but we know
Yeah.
that one works. But now, we might find some other things that people are more likely to adhere to.
Yeah. You said a good point in our in last time I interviewed you, we had that conversation. The best benefit to exercise is actually going from nothing to doing something,
Yeah.
and not generally from, somebody who's an athlete doing just a little bit more. The benefit there, the delta there isn't that much, but the delta,
Right.
the change, and from just doing nothing, getting off the couch and doing something, whatever that is, that's the biggest benefit. I've I've used that a lot in conversations. So I said,
Yeah,
huh,
it's astounding how much
yeah,
benefit there is just from some movement.
yeah. Well, what else? What other points do you want to make? We need to give information on where people can enroll, where they can find you, where they can find out more about this. So please share all that stuff here. What do you say?
Yeah, so it's available on the OMRF website site, and you'll put that in the notes. You contact us, you go through a phone screening first, so we don't waste any of your time by bringing you in when you might not qualify. You get to see OMRF. I
Hmm.
encourage people to go look at OMRF too. And
Yeah,
we went out in the state the last 2 years to make people more aware of this, what OMRF is, because it's a smaller place. It's not as big as OU and things like that. But we do, like, I personally am here because of the science at OMRF. I'm not an Oklahoman. I'm here because of the great science here
right.
at this institute. And I encourage people to explore that as well. Just some of the great things going on here.
Yeah,
But yeah, going through the website, seeing the study there, there's a pre-screening form there for them to check out, and hopefully get some people enrolled. You don't have to do it right now. I mean, we're recruiting over the next probably 4 years, so these
okay.
things tend to go in 5-year cycles. So
When will
yeah.
so if somebody enrolls now, when will they actually start in the program? When is that set up to lined up to initiate?
A couple weeks right now, but we
Yeah.
can we can also work with people to when they'd want to start. Yeah.
Okay.
We're, we try to be as flexible as we can. We know people have real lives, and we're
Yeah.
trying to work this around the other things they do.
Right. Gotcha. You know, you, You made a good point. I do recommend anybody to go check out OMRF because it is really a cool, beautiful facility.
Yeah,
You work in a cool spot.
yeah, I like it too.
Yeah, yeah.
One other thing with our study too, we'll mention that, we welcome everybody. Like we're looking for, representation, if you're African American descent versus, Caucasian versus Hispanic, whatever, these are all going to be slightly different genetic factors and stuff. So
Hmm.
we are trying to get a representation of all Oklahomans in this study. So we encourage everybody to look into it.
Yeah. Well, cool. Well, man, I really appreciate your time. You made a good point. A lot of people in the scientific community where you're at don't really do a good job in talking to the public, they kind of stay in their realm. And you do a really
Mhm.
good job at that. I've heard you speak to everybody and you do a really good job at conveying those points to the average human. So we're
Yeah,
lucky to have you.
it's something I work at. It's a skill. I mean, it's
Yeah.
something that, yeah, all scientists could work on that a little bit better. But yeah, it's definitely something I've invested energy into doing because of how important it is.
Yeah. Yeah. Well, are there any other points you want to make, Ben? I really appreciate your time.
No, I think I'm good. We covered a lot of ground there.
Okay, cool. Well, thanks for your time. Grateful to call you a friend, and I sure appreciate what you're doing. And I'm excited about this new project you have. I think you'll have a lot of interest in that. So, very cool. All right. All right. See you guys later.